Hello guys, we are doing AMC 12A 2021 4, problem 4. Let's get started. The problem is short. We have a 6-digit number. 20210A is a prime for only one digit A. What is A? Okay. Let's get started. I think this problem tells us some property or the necessity condition for an integer is divisible by 2 or 3 or 5, things like that. Of course, since a is the last digit, it can't be an even number, so it can't be 0, 2, 4, 6, blah blah blah. And of course there's no choice there, and because that is easy to be excluded. And now we can apply our first filter, and then which is the divisible by 3. And I think everybody knows that if an integer divisible by 3, that is equivalent to the sum of all the digits, like 2 plus 0 plus 2 plus 1 plus 0 plus a. I believe this is equals to 5 plus a, right? And this is modulo by 2 plus a and modulo by 3. So so we know that a cannot modulo by -1, no, +1 if modulo by 3. So that means a can't be, a is not equals to 1 or 7, 1 or 7, right? Okay. And then the next prime number, so so the trick of this is we go through all the prime number from the smallest to the largest. Of course, there's no largest, but just go from 2 to 3 one by one. So the first is 2, but for 2, there's no even number in the choices, so we exclude all of that. And the next prime is the number 3, and then using this condition, we exclude 1 and 7, right? So then the next thing is we want to do 5, and then what is property 5 is just a is not equal to, so the last digit is not equal to 1 or 5, and then we can exclude 5. So what's left here is only 3 or 9. Okay, so we only have one more to exclude. And 7, the next prime is 7, but the thing is a little bit difficult to do. And the next trick probably is we can test 11, right? So what is the property of the integer who is divisible by 11? I think this is a less common trick. If you know that, that is fine. If you don't know that, probably we can derive it here. Let's see, we have some numbers that is equals to like a, b, c, d is 4 digits. So if we want to represent the numbers in basis 10, is actually this number is equal to a multiplied by 10 to the third power plus b multiplied by 10 to the second power plus c times 10 plus d. And under the condition of modular by 11, you see this is very good. Why? Because 10 is just equal to -1. So we like 1 and -1 because 1 and negative 1, any power is just equal to 1 or negative 1. So here we know that 10 to the third power modular by 11 is equal to negative 1, right? Because it is negative 1 third power. And then plus b negative 1's second power plus c to negative 1 plus d. So it's actually equal to negative a plus b minus c plus d, and then modular by 11. So as you can see here, a number that is divisible by 11 is actually equals to, you do the digit in the alternative way. So you start from the last digit, which is positive d, and then go to negative c, positive a, and negative a. So you see the pattern here, and this rule can be easily expanded to other number of digits. So we have 2, 0, 2, 1, 0, a. So basically this is a, negative 0, positive 1, negative 2, positive 2, right? So, right, this is 1, negative 1, positive 1, negative 1, positive 1, negative 1. Okay, this is negative 2. So, modular by 11, actually this one is equal to this. So this one is equal to a minus 3 modular by 11. And remember, we have choices 3 or 9. And by modular 11, this one can't be equal to 0. So that means a is not equal to 3, and thus we know that a is equal to 9. Boom, we got the result. So we choose number E. Thanks for watching. I think the tricks for here is to apply the rules. I believe for 3 is easy. It's modular to the sum of all the digits. For 5 is also easy. It is 0 or 5. And for 11 is need a similar trick as 3, but you know the modular of 10 by 11 is equal to negative 1. So it's just alternating, and then you can exclude 3. And finally you got 9. Thanks for watching.